Okay, folks, so here's the answers to the flipped classroom. So this is both question 7 and question 11 from the last year's test. That essentially asking you to, can you label these as precipitation, acid base, redox, or neither? And can you label them as combination, decomposition, single replacement, double replacement, or I guess technically neither? So let's look at each of these in turn. I will eventually be coming back to this uh, chart as I need to. First step is just labeling the reaction as single, as a simple thing. Combination, decomposition, single replacement, double replacement. So with this, combination is two or more compounds / elements becoming one. Decomposition is just the reverse. So hydrogen peroxide breaks apart into two or more things. Decomposition. That's what. Double replacement and single replacement. Single replacement, an element and a compound switch. The key is an element. Double replacement is two compounds switch. So H plus switches with calcium. We see here. And so this guy is just a double replacement. There will be a lot of double replacements. Now, technically, you might be able to say, like, this is maybe a double replacement, but you might just say it doesn't easily fit into any category. So neither is good enough. Neither for that guy, because two elements are not coming one. Two elements are not coming one. One thing isn't breaking apart into two. There's no pure elements, and technically, since the nitrates and whatnot, this nitrate is transferring over there, but other than that, wouldn't really call it either. Finally, zinc and K are swapping places, so this is another double replacement. Double replacement. That's it for the first four. The second four, with that in mind. Two different things are becoming one. Sure, there's four of these, but two different things are merging to form one big thing. So this is a simple combination. Combination. Two compounds are swapping. So this becomes a double replacement. Here's a pure element, and a compound. Swap places. So this is single replacement. Now this is a little bit harder to see, but two compounds swapping places. The H and the Li are swapping places. So this is also a double replacement. Now that has answered the easy question for all 8 questions. The hard question is redox, acid base, precipitation, or neither. So step one is always look for the red flag of redox. I put these in order of ease to do. Step 1 is look for any pure elements. A pure element is a dead giveaway that it is redox, because pure element is always charge 0. Well, that means the that means something has to be losing electrons to get to charge 0. Something has to be gaining electrons to get to 0. So hydrogen peroxide is both losing and gaining, but so it's a redox. So moving on to the second one. I do not see a pure element. Compound, 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 compound. So if there's not a pure element, I move on to checking for acid and base. Why check for acid and base next? Because I can do that by looking at the chemical formula without going to the chart. Acid base, I'm looking for an H plus and an OH minus go to water. And I have an AH plus and an OH minus go to water. I need all three. If all three are present, it is an acid base neutralization. If I were to say the names, nitric acid and calcium hydroxide, which is our base, go to water and calcium nitrate, a salt. Nitric acid, an acid, and a base go to water. Okay. Now, step 1, check for pure element. Compound, 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 compound. No pure elements. Acid base. Is there an acid? No. Is there a base? No. So, move on to precipitation. So, with that in mind, I need to check the chart. Check the chart. So, I look for products. Any product that has insoluble means it's precipitation. So, iron nitrate. So, I scroll over here. I look at my nitrate column. Down to iron, and I look at the copper. Both of those are S. S stands for soluble. Anything that is soluble means it's aqueous. Anything that's aqueous means it is not a solid. So with that in mind, the step 4, and this is the hardest step, check the charges. Recheck your redox. If a charge has changed, it's redox. If a charge has not changed, it is neither. So nitrate, by nature, is -1. So copper must be +1. Iron must be +3. So if nitrate is -1, then iron must be +2. And copper must be +2. So iron goes from 3 to 2. Iron is reduced. Copper is going from 1 to 2. Copper is oxidized. So this is redox. Even though we're like, it's really hard to see. It's hidden. It is redox. As far as this one, step 1, no pure element, no pure element, no pure element, no pure element. Step 2, hydroxide but no acid, no water. So it's not acid base. So next is to go to the chart. So I look. So potassium sulfate. Potassium is in row 2. Sulfate is in column 3. It's soluble. But zinc is in 1, 2, 3, 4, 5, 6, row 6. Hydroxide in column 6 is insoluble. So insoluble means this is a solid. If this is a solid, it is, by definition, a precipitation. I ask you to do those in those orders because then you can go easy to hard. Easy to hard. So step 1, look for pure element. Pure element. I can stop redox. Step 1, pure element, no pure elements. Step 2, acid or base, no acid or base. Step 3, solubility. So let's look. Magnesium, row 3, nitrate, column 1, soluble. Cadmium, row 6, sulfate, column 3, soluble. Crap. So it's not a precipitation. Now I check my charges. Nitrate is 1 minus, cadmium is 2 plus. Sulfate is 2 minus, magnesium is 2 plus. Magnesium is 2 plus, and cadmium is 2 plus. No charges change. So even though it's a double replacement, we do not have a driving force. There is no driving force on this reaction. Last two. Pure element. Pure element means this is a redox. Almost all single replacements have to be redox because they involve a pure element. Finally, no pure elements. Okay. We see a hydroxide, we see water, and we see this H being lost. How do we know this H is being lost? Because look, we have this molecule. I'll put a box around here. What's different between this molecule, whole molecule, and this is that the one less H. So this H plus, OH minus, goes to water. This last one is an acid base. So all in all, this was not meant to be overly challenging. It's something that you can do, and hopefully you found this relatively easy. Have a good day.